Hello everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were doing our pattern wise DSA sheet, and in this we were learning binary search, and today we will start the very last pattern of binary search, which is search in a 2D matrix. Yes, it is different pattern. Why this is different pattern? We will learn this via question. So the very first question is search in a 2D matrix. So as you can see the problem here, so let's read the problem statement. The problem says we will be given a m cross n integer matrix with the following two properties. These properties are very important, which will help you decide whether the logic, like whether the binary logic will be applied or not. First is each row is sorted in non-decreasing, means increasing order, means each row will be sorted in increasing order. If you see 1, 3, 5, 7, yes, sorted, 10, 11, 16, 20, sorted, 23, 30, 34, 60, sorted. Second property is first integer of each row is greater than the last integer of the previous row, means first integer, you can see 10, suppose 10, so first integer of each row is greater than last integer of previous, means 10 is greater than 7, yes, 23 is greater than 20, yes. And how these two properties can help us solving this problem using binary search logic, let's see. As you can see in the screen, the 7 is lesser than 10, okay, 20 is lesser than 23, okay. Suppose the question asks us to search target, okay, and target is nothing but suppose 3. Okay, your task is to return true or false. Here you can see you have to return true if the target found, or else false. You must write the solution in logarithmic of n cross n. Why it has been mentioned? Because most of us can think of searching it with linear approach, and that will cost you m cross n because number of elements, which is m cross n. And the question asks you to do in a log of m cross n, means you have to apply the binary logic here. Let's read the constraint. Constraint is around m and n is around 100. Anyhow, m cross n will become 10 power 2 into 10 power 2, 10 power 4. Obviously and definitely it will pass. But the question itself mentioned that you have to submit the logarithmic solution, means you have to apply the binary logic. Okay. So suppose you have to find the target 3 in this matrix, and you're not allowed to do the linear search. How you would like to search? Okay. So what you can think with the binary search? Can I say one thing? Ki if because this extra property has been given na, ki 10 will be greater than 7. So can I say ki, see, ask this last row with 23, ki is 23 is greater than target? 23 is greater than target, yes. So can I say this 3 cannot be found in this row and anything towards its down? Yes. Again, 10, is this 10 less than target? 3 or greater than? Yes, it is greater than. Means 3 cannot be in this row because 10 is the smallest element of this row, na? And if 3 is smallest than 10 also, then 3 cannot be in this row or anything towards its down. Okay. Okay. So we are somehow able to relate this with binary search. Yes. So if we will find out this 10. Okay, how to decide? We have to compare it with 23 or 10. That's where binary search comes into picture. Means we have to apply the binary search logic in the row first to get the valid row. Valid row here means that row which actually or which might consist the target. Why I said might? Because in this question it might happen ki suppose instead of 3, 4 is given. So definitely as per the definition 3 should lie inside it, but as 3 is not there, so you have to return false. But still you have to apply or search in this valid row only. So hence valid row is that row where the target might be present if it is there. Okay, so first we will apply the binary logic but on the rows to get the valid row first. And how we can apply? We will put like your starting point and your ending point here. Okay, and with what we want to compare? With the first value of every rows. Can I say this? Yes. But I want the mid value, na? So mid value means nothing but row, mid row. Because left and right is at 0 and second, so mid will be 1. So we want to search, but not entirely. We want to compare this with the first value of or first element of this mid row. And 10 will say ki yes, it is lesser than me. So your answer will lie towards upside. correct? So can I put my right pointer from here to mid minus 1? Yes. So basically what I am saying start your left pointer from 0 and right pointer from what? Length of rows. So length of rows, suppose rows minus 1. Okay, now we want to calculate the mid. So mid we can definitely calculate with left plus right divide by 2, or else left plus right minus left by 2, depending on the constraints. Okay, so we will calculate the mid index. Now with what I have to compare? That will be if matrix of row will be mid, definitely. And with what element we want to compare? First element, so 0. Okay, if this value is greater than target, so can I say ki my answer, like you can see 10 is greater than 3, so definitely 3 cannot be present in the mid or downwards the mid. Yes, so can I move my right pointer, which is sitting at the last row, can I move it to mid minus 1? Yes, so I can definitely say right is equal to mid minus 1, correct? Yes. Else if, why I am saying else if, let's see. Else if matrix of mid of 0 is less than target, okay. Now suppose the target is 23, correct? So 10 is lesser than 23, so definitely it will fall in this else if case now. So what I want, can I say the answer can be in this mid also or this also? Yes, still confusing, right? Because instead of 23 it can be 11 also, no? If it is 11, so definitely we have to search in the same mid row, or else if it is 23 we have to go towards this downwards, means excluding the mid. So can't I do one thing, means instead of this or before this, so we will write if matrix of mid 0, okay, if my target is greater than equal to the first value and my target is less than equal to the last value of mid row. How to read the last value? Nothing but columns minus 1. Okay. If this is the case, can I say suppose my target is 11? So definitely target 11 is greater than 10? Yes. And target 11 is less than 20? Yes. So can I say my valid row will be the exactly mid? Yes. So I can simply say ki valid row is mid, and I don't want to search in this case because we were applying this binary logic to only find my valid row. So I can simply break this, correct? Break it. Yes. Saying I have found it, so why to unnecessarily move? Okay. Now I have find the valid row. Now take it as a 1D array. Sorted 1D array, and now apply the another binary logic, binary search on this row, correct, to find the value. If it is there, return true. If it is not there, return false. Okay. Okay, so what we did here, first we initialized the left and right pointer from the first and last row, calculated the mid row and compared ki if my target value lies in between this to this. So definitely we don't need to search anything. We just need to save that mid in the valid row variable and break that. Okay, but here so we saw ki target was 3, so definitely we have to check ki if our first element of the mid row is greater than target. Yes, 3. So definitely we can say ki our target does not lies in mid or any row beyond this or downwards this. Yes, so we can move our right pointer, which is sitting at the end, we can move towards the mid minus 1, saying ki the target will be in the upper half. Okay. Else if suppose our target is 23, so definitely 10 will say ki no, it is greater than me. Yes, and if it is greater than me, I can definitely move towards the downward, means mid plus 1. So I can move my left pointer to mid plus 1. Now if you are thinking ki why mid plus 1 and why not mid, because if it was any number from 10 to 20, that would have covered in the same first if case na. This is the first if case, this is the second if case, this is the third if case. So if any target which has not passed this first if case, means it does not lie between 10 to 20 and it says ki I am greater than 10, so definitely it would lie towards the downside na. So definitely we have to go move our left pointer to mid plus 1, saying ki this target is beyond the mid value. Okay, and by running this valid binary search we can find the valid row, and once we found the valid row, and that valid row is not like, it should be a proper value, means from 0 to last row it should be any value, then only we can say ki the value is there. Suppose if I want to search a number 61, so for that we cannot get any valid row, na, because last row will also say ki no, 61 is not in me. So definitely this while loop, this binary search, first binary search to find the valid row will end up saying ki 61 is not in me. So if 61 is not in me, then we can simply return -1. But in this case, as target was 3, so valid row will be 0 index, and now we have to apply the binary search logic in this first row, and again we will initialize the left pointer from first column, last pointer from last column, and now we'll calculate the mid value. If it is equal, we will return true. If it is lesser, we will move towards the right side. If it is greater, we will move towards the left side, and so on, like basic binary search. So hence we have applied the binary search for 2 times. One time we applied to find the valid row, and if you will see how many times we have applied, which is nothing but number of r times, which is log of r. And once the log of r, after this we have applied the binary search on that row for how many number of times, we can say number of columns, correct? So hence log of c. So if you see, log of r plus log of c is nothing but log of r into c, which is nothing but m into n. Now the question is ki how we have applied the binary logic, and one reason is definitely it is sorted. But another question is ki why we applied the binary logic on the rows only to get the valid row, and then applied the on columns. It can be like this, na, ki why not applied on columns, and then once we got any valid column, then we applied on rows. We could have done that way also, na. Have you thought? Yes, we cannot do that way in this question. Why? Because the question says ki it is row wise sorted. Yes. Column wise sorted. Yes, definitely. And the 10, like the first value of the row, is greater than the last value of the previous row. It means it is talking about the rows. So if you'll open row wise, na, open this 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34 and 60. Okay. So if you will open this now, it is sorted. How many number of elements are there? Number of rows 3. Number of columns 4. So total 3 into 4, which is 12. And see here, count it, it is number of 12 times only. So when you apply a binary logic on size, on n size, suppose n size, so log of n time complexity you takes, na, and here I am saying ki the total number of elements are row into column, which is basically as per the question m into n. So can't I say ki log of m into n only? Means log of m plus log of n. Means this itself says ki apply the binary logic on number of rows, then number of columns. Now the reason we applied the binary search logic on the rows only, because it said ki every rows, like every first value is greater than this. Now instead of this, if the question would have said ki every columns, like every column's first value, like 3 is greater than this, then we could have applied that logic of binary search on applying it for column first to get the valid column, and then we would have applied the binary logic on rows. So how it would have looked like, instead of all these values, it should be sorted in row wise and column wise for sure, but it will be like this ki 1, 3, 4 and then 5, then 6, then 7, then 8, then 9, 10, then 11, then 12, 13. So here if you will see, it is row wise sorted, yes, column wise sorted, yes, and every first value of the columns is greater than last value of the previous column. Okay, so now you have to find the valid column where your target could lie, and in this case you will apply on columns. Once you get the valid column, then apply the binary logic to find the value in that column. What will time complexity for that case? Same, first log of n, then log of m. Means log of c, then log of r. Anyhow it is same, correct? So here is the code for that. First we have calculated rows and columns in m and n. And then we have initialized the variables called top and bottom because we want to apply the binary logic on the rows first to get the valid row. Okay. Now the valid row we will save in the row variable, which is with -1. And now we want to apply the binary logic here. So while top less than bottom, we found the mid index first. And then we first check key, does our target lies in that mid row itself? If it is, then save that valid row in the row variable and break it. Otherwise, if your target is less than the first value of that mid row, then we can say our target lies in upward matrix, and for that we can move our bottom to mid -1 or else mid +1. Once we got it, obviously our row will not be -1. If it is -1, it means our target value is not in that matrix and we can return false then and there, correct? Or else, if it is true, if it is not -1, means we have found the valid row and now we have to apply the binary search or logic on that row. So now we want to run another binary search, and for that we initialize the left and right variable from 0 and n-1, where n is nothing but number of columns. And now we'll write while left less than right. We will calculate the mid index now, and if the matrix of, now we want to search in what row? The row which we have found, valid row, and column will change, where column we will decide with the new mid, because now we are applying the binary search on mid. So now you can see mid changes. So if the mid value is equal to target, we'll return true, yes found, or else if that value is less than target, we will move towards the right side by mid +1 or else mid -1. At the end, if we have not found anything, like even if we have found the valid row, but still it might happen that the answer is not there. Suppose if we have to find the target equal to 4, so even if we have found yes, 4 can lie from 1 to 7, but you can see 4 is not here. Okay, so second binary search cannot give you true also. So if you are outside this loop, you can say yes, you have not found the value even if you found the valid row. So you can return false there. So this is your Java code. Okay, so now let's run this. As you can see, the test cases has been passed. So now let's submit this code. And the time complexity is log of n into n. And you can see that it has been passed successfully. So here is your Java code. I hope you have understood. And here is your Python code if you are from Python background. And here is your C++ code if you are from C++ background. All the logics are same. The only difference is the code languages differs. And with this, we can go in our sheet and we can mark the very first question as to be done. I hope you guys understood. If yes, then do let me know in the comment section understood, and I hope you all are submitting along with me. Writing the code on your own is very important. Don't just copy paste. Close the tab, close the window, and please try to write this on your own, either with pen and paper. That will be the best option, because until or unless you are visualizing on yourself, you cannot understand, and binary search is a little bit confusing, yes. But if you practice a lot, you will be able to understand when to move towards right and when to move towards left. And that's it, guys. If you are new to this channel, we are following the Rising Brain pattern wise DSA sheet that is totally free of cost. You can find the link from the description, and if you want to connect with me on any of the social medias for any guidance, do reach out to me. All the links will be there in the description. And I hope these videos are helpful for you. You are learning how to identify patterns and all on your own. That is the only agenda of this YouTube playlist. And guys, a special request, if you feel all these videos are helpful, do like and comment on this video, and you can share with your friends also if you feel that will be helpful for them. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.